Hello, today we're going to talk about the probability using fundamental. All right, a quick review of the fundamental counting principle. It's written as M times N. So if I had, I was trying to choose my outfit for the day. I said I had 4 sweaters. What do I have? 6 shirts and 5 pairs of pants. How many choices do I have? 4 times 6 times 5 equals 120 outfits. So that's basically just the fundamental counting principle. Now we're going to add some probability into it. All right, here's our first example, and it's kind of long. We're going to do 3 different things with it. So up here I have a chart of meals you can get at a restaurant. So you can pick one of your sandwiches, one of your sides, or one of your drinks. So the first thing we want to know is the possible number of outcomes. So that's 4 times 3 times 5, which gives us 60. So you have 60 possible outcomes here. Now what is the probability of a customer coming up and ordering, making an order with all 3 things? So say they want a hamburger, chips, and water. Alright, so that would be, so I have 1 possible choice here, times 1 possible choice here, times 1 possible choice there, so I get 1. 1 over 60 would be my answer of a customer coming up and picking those 3 things. Alright, it's pretty simple, but what if I said I wanted a hamburger, chips, and water plus an apple juice? What is the probability of that happening? All right, so still I have 1 hamburger, still I have 1 side of chips, but now I have 2 possible drinks. So then that gives me 2 over 60, which is 1/30. So let's take this one step further. Let's say I want all 5 drinks. All right, so it's still this up here, still 1 hamburger, 1 chip, but now I have 5 drinks. So that's 5 over the possible number of outcomes, which is 1/12. And there you go. You just switch. If you make a chart like this every time, and write out your possibilities, it makes it a lot easier for me at least. This is basically what we're going to do through the next 5 examples. Alright, so this first one's about a PIN code that's 4 digits long. Alright, and the numbers can be between 0 and 9, and each digit can be repeated if it wants. So let's start by finding the number of possible outcomes. So if it can repeat, and you have to choose numbers 0 to 9, how many choices do you have for your first one? You have 10 choices because there's 10 numbers. Same thing with the second, same thing with the third, same thing with the fourth. So you have 10 choices for each one because they can all be the same number. So you do 10, so to find the number of possible outcomes, 10 times 10 times 10 times 10. That gives you 10,000. 10,000 different choices here. Now I want to know, what's the possibility of them all, or what's the probability of them all being identical? So like 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, and so on and so forth. So if there's 10 numbers, that means there's 10 possibilities here. I'm not going to write them all out. So then my number of desired outcomes is finding, so what I'm looking for is when they have all the same numbers as 10. So I simplified that down to 1 in 1,000, that they are all going to have the same number. All right, for this one we're going to flip an unbiased coin, which means it should be 50%. chance of getting heads and tails each time. So what is the possibility of me flipping a coin 4 times and getting heads every time? All right, let's find the possible number of outcomes first. So my first flip, there's 2 possibilities. Second, third, you have the same number of possibilities for each one. You're gonna get heads or tails. So the number of possible outcomes is 2 times 2 times 2 times 2, which is 16. All right, so what are the chances of me getting 4 heads in a row on this? Or what's the probability? So for my first one, there's only one thing I want. For here, there's only one thing I want, here and here. So for each flip, there's only one chance of what I want to get. So 1 times 1 times 1 times 1 gives me 1. 1 over 16 is the probability of me getting 4 heads in a row in an unbiased coin. All right, for this example, we have a bag that has 4 different color balls in it. Red, green, red, and yellow. All right, I'm gonna draw twice out of the bag. So draw. So what are the chances that I draw 1 green ball out and then any other color, it doesn't matter, each time? So let's find our possible outcomes. So there's 4 different color balls. So my first draw, I have 4 different things that I can get out. My second draw, there's 4 different colors that I can draw. So number of possible outcomes is 4 times 4, which is 16. Now, what are my number of desired outcomes? So I can draw, on my first one, I can draw green. On my second one, I can draw any other one that I want. On my first draw on my second one, or on my other example, so I could draw any other color and then green. And then my last one, it could be green and green. So there's 3 different possible outcomes. So then I get 3 over 16. So my number of desired outcomes, 1, 2, 3 different ones. My possible outcomes is 16, so 3 over 16. All right, for our next example, we're gonna talk about buying a car. We're gonna go with more options here. All right, so this is just the further probability calculations. So let's say there's 10 colors you can pick from of this car. Whether you can have a sunroof or not, so you have 2 options. Whether you put a spoiler on it or not, so 2 options. And whether you have leather seats or not. All right, because you either want them or you don't. All right, but you have 10 different colors to choose from. So what is the number of possible outcomes? Well, it's 10 times 2 times 2 times 2, which is 80. Now what if I said I want a car of any color, doesn't matter what color it is, but I want it with all the amenities or all the fixins or whatever you want. So I want the sunroof, I want the spoiler, I want the leather seats. So the number of colors is 10. I don't care what the color is, just give me the special one. So then you want the sunroof, so there's only one possibility there because you don't want it. You want the spoiler, so there's only one possibility. You want the leather seats, only one possibility. So 10 times 1 times 1 times 1 is 10. 10 over 80 is 1/8. That's the probability. All right, my last example for this probability using fundamental counting principle. So say I have 2 coins and a cube. So when I flip my first coin, I have 2 options. I'm either gonna get heads or tails. When I flip my second coin, I only have 2 options, heads or tails. Let's say I roll a cube. How many different options are in a cube? 6. So to find my total number of possibilities, 2 times 2 times 6 gives me 24. All right, so I want to know the probability of, with my first coin flip, going heads second tails, and then roll in an even number here. So I have a total of 24 different outcomes. Here, I have one chance of getting a heads, one chance of getting a tails. But then how many even numbers are on a cube? 3. 1 times 1 times 3 is 3. 3 over 24, which is 1. Alright, this has been probability using fundamental counting principle. Hope it helps and good